Okay, this is lesson for day 148, geometric sequences. So I'm teaching this right now because you should have learned this in Algebra 1, but you didn't because it used to be taught in Algebra 2, and now it's taught in Algebra 1, and it's actually very easy, and it has to do with exponential. So remember a few days ago we talked about arithmetic. And we circled arithmetic. What was arithmetic mean to you? Linear, right? Linear. Geometric sequences, I want you to think exponential, okay? So, exponential. So, I'm going to ask you to take your title and just circle that word geometric and put exponential for me, okay? Are we all doing that right now? Okay. So, arithmetic is when you're adding the same amount every time, so it becomes linear. Geometric sequences are exponential because you're multiplying by the same amount every time. Okay? Yeah, what's up, bud? No, keeping that up there as a reference. Yeah. Alright, so if you're on the video, you want to write this down, take a moment to pause the video and write this down. Okay. Here we go. So I'm going to start us off here. Ready? I'm going to actually jump to number 2 first because I should have put number 2 first so you could get the concept, okay? So this is just like before. Is there a pattern on number 2?
Yes.
Yeah. What's happening on the pattern on number 2? Is it being added by the same amount every time?
No.
No. Okay. So is it arithmetic sequence?
No.
No. What's happening to it?
Multiplied by 3.
Okay, multiplied by 3. Good. Okay, ready? So on this one, you'll notice that it's being multiplied by 3 each time. Okay, so our ratio, we have this thing, it's not a difference, it's not D is equal to, it's going to be R, because it's a ratio. It's a common ratio of 3 every time, meaning each number we're going to multiply by 3 to get the next subsequent number. So you see how it gets to 108? What would the next one be then? What would you predict the next one to be?
324.
Excellent, 324. And then after 324, what do you predict the next one to be?
982. 92. Wait, what? 900. Wait, lower? 900.
300 or 972.
Oh.
Okay? Close, good. Does that make sense, everyone? Okay, cool. So, we're going to make an explicit rule now. We know this is a geometric sequence because it's being multiplied by the same amount. And now I'm going to make a rule, just like we did yesterday or 2 days ago with the explicit formula for arithmetic sequences. We're going to make one now for explicit formula for geometric sequences, which is a rule. It says, like, hey, this is what it's going to turn out to be. All right? So, start with figuring out what's your first term on the sequence. It's 4. We know the ratio is 3. And now we're going to identify, okay, this is the first, second, third, and fourth term, a sub 1, a sub 2, a sub 3, a sub 4. And then you just start off with step 2, which is following or writing down the explicit formula, the basic part of it, and then we're going to replace the terms that we need to replace. So a sub 1 in this example is going to be 4. Okay, so I'm going to replace it with that, and then our ratio in this example is positive 3. And then we write n minus 1, and we're done. Okay? And what this does is it gives us the ability to get any term, okay? So, for example, the second term, okay? Ready? If I wanted the second term, we're going to replace n with 2. What's 2 minus 1?
1.
What's 3 to the first? 3 times 4? 12. Isn't that the second term here? Do you see that? Or let's try the fourth term. I know the answer is supposed to be 108, but let's just see if it works. What's 4 minus 1? 3. Good. What's 3 to the third, which is 3 times 3 times 3?
27.
27. Good. What's 27 times 4? 108. You see that? So, the fifth, let's say we were trying to find the fifth. I know that Jonathan already did it. He did it quickly in his head. Okay? So, let's put in 5. What's 5 minus 1? 3 to the fourth, which is 3 times 3 times 3 times 3. 81. 81 times 4?
Thank you. 302. 324.
81 times 4. Okay? Does that make sense? So this is like a rule, okay? All right, let's keep going. Let's do number 1 up here. I'm coming back. Now, what is the pattern here? Is it being added by the same amount, like an arithmetic sequence? No. What's happening in this pattern here?
Subtract 3, add 6, add 12.
Okay. So is it a consistent addition?
No.
No. Is there anything else happening? Is there a consistent multiplication happening?
No. Wait.
That's timesing it by
Times -2.
Good. Timesing it by -2 each time. -1 times -2 is +2. +2 times -2 is -4. -4 times -2 is +8. Y'all see that?
Yes.
Awesome. So what we're gonna do now is we're identifying the ratio as -2, right? And our first term in this sequence is -1. I know it's geometric, so I'm gonna use the explicit formula for a geometric sequence, which is a sub n, which is equal to a sub 1 times a ratio to the n minus 1. Okay? So we just replace it. We replace the values. A sub n is equal to -1 times -2 to the n minus 1. Okay? And that's your answer. All right, we can figure out any term we want using this. Okay? So what if I wanted the 6th term? Okay, ready? 6th term. 6 minus 1 is 5. What's -2 to the 5th power?
-2 to the 5th power. That's going to be
Almost. You're so close.
positive.
Nope.
32.
It's not 32.
Positive 32.
Nope. -2 to negative. Aha, good. What is it, David? Really? Yeah. Is 32 the same as -32? No, it's not. Okay. Sorry, I'm not trying to pick at you, but we want to be specific, right? Don't get mad. Okay, good. Okay. What's -32 times -1? What's -32 times -1? Positive 32. Right? Do y'all see that? Okay, cool. There you go. So that's how you do numbers 1 and 2. Now, we use, remember how I told you arithmetic sequences, ladies in the back? Please focus while I'm teaching you, okay? You'll have time to talk later, I promise, okay? So, remember our arithmetic sequences are you adding the same thing over and over again, and it has to deal with your money every month, right? If you go out to eat every month and you spend $200 a month, how much is that after a year?
A lot.
No, it's more. $200 a month.
2,400.
2,400. Isn't that a lot of money?
Yes, it's
That is a lot of money, right? That would be like how many weeks of someone working 15 hours a week at Cold Stone? It's a long time, right? It's like almost half a year, I think, right? It's a long time. So, geometric sequences have to do with interest. You know how you invest money at the bank and they give you interest? It's exponentially growing if you grow your interest on top of interest. Or let's say you borrow money. Let's say you borrow money to like buy a car. You know, you're not really paying what you borrow. You're going to pay what you borrow plus the interest that accrues, which is, it adds up pretty quickly. Okay, so we'll talk about that in a few. Anyways, let's have the 3s in my class today. 3, 3. There's no 3 today, so it's easier. 3, 3, 3, 3, 3, and a 3 in the back. Can you all please talk to your neighbors and tell them, how do you figure out, is it a geometric sequence? If so, what's the ratio, and how do you create this equation? Okay, ready, set, and go. Ready? Let's move on here. Let's move on. Okay, number 3 and 4. Remember, you're figuring out, is it a geometric sequence? If so, what is the ratio, and what's the equation? Okay, with your groups, we got 4, 12, 20, 28. It's a sequence. Talk to your groups. What's the pattern?
It's going up by 1. No.
Michael?
I was telling you.
Okay, don't be gross. Let's talk about number 3. Okay, what do y'all think about number 3? Is it a geometric sequence?
No. Arithmetic.
Arithmetic?
Plus 8.
How is it an arithmetic?
It's added by a constant sequence of 8.
It's growing.
It's odd.
It's growing by what? 8. So the common difference is 8. Okay, so since it's arithmetic, we're just going to write that down. It's not geometric, so we're done with this. But if it was like a test, if I wanted you to like complete it, you would know how to do that already. We're not going to spend time on that right now. Yes? That was your question? What was your question? Are you sure? You don't have to be scared or embarrassed. Okay, here we go. Number 4. Well, ask me a question if you have it. Number 4. Turn to your neighbor and tell him, is this geometric or not? If so, what is the ratio? And then write the equation out. Write the equation out. Go. 4. Good. Okay. So what is the equation then? Oh, is it geometric? Is it a geometric sequence? Yes. Okay. So what is it? Y equals what? No, it's not 4. Y equals 4. What is it?
Oh, it's n equals 1 parentheses 4 n minus 1.
4 to the n minus 1. You have to be specific. Not 4n minus 1. 4 to the n minus 1. Okay?
Oh, you don't put that parentheses in there?
No, you don't have to. Okay, so this is the correct answer, the second to last answer, and the simplified answer. Yep. Because what's 1 times anything? Itself, right? Or whatever you're multiplying with. Okay? Cool. So I think we're good with this lesson, so I'm gonna end it there. Huh.
Can you go back to the last one?
Sure.